All right, we're going to be taking a look here at integration here. We've got our first problem here, the integral from 0 to 5 of x to the power of 3 halves, integrated with respect to dx here. When you're calculating your integral, you want to think of the function whose derivative is going to be x to the power of 3 halves. Recall that we do have the power rule. The power rule states if you have x to the power of n, then that derivative will be you drop down that n and subtract 1. So therefore what I need to do here is I need to think of a number such that when I subtract 1 from it, I'm going to end up getting this 3 halves here. That's going to be 5 halves. But when I go to take my derivative here, we drop down that 5 halves and subtract 1. We get the 3 halves that we want, but I don't want this 5 halves here. So I have to add in a 2/5 into this expression. And now we have the integral of x to the power of 3 halves. And then we're going to evaluate that from 0 to 5. Substituting this in and evaluating, we get the following. And you can see here I value this function at 5 and then subtracted by the function at 0. If you take a look here at 0, this just becomes 0, so that's done. And then I have this expression here. I took the 5 to the power of 5 halves. I broke it up into your 5 squared times 5 to the power of a half. And we get some cancellation here, and we end up getting our final answer as 10 root 5. Let's take a look at another example. In the next example here, we're taking the integral from negative root 3 to root 3 of the following function here. Again, the product of these two binomials. First thing to do is we're taking this with respect to t, so we're going to expand this out and see what we get. Expanding out, we get the following. Now that I've expanded this out here, we're going to go ahead and when you apply your integral, you can apply it to each one of these terms separately. So I'm going to go ahead and find the antiderivative of each of these following functions here, which will give us the following. So you'll notice here I went ahead and took the antiderivative of each one of these separately. And you'll see here by taking the derivative of 1/4 t to the power of 4, you'll get your t cubed. The derivative of 2t squared gives us 4t. The derivative of 1/3 t cubed will give us t squared. And the derivative of 4t gives us 4. We can now evaluate this integral from negative root 3 to root 3, giving us the following. All right, you'll notice here I value the function at the square root of 3 and then the function at the square root of minus 3. We don't want to go ahead and do all these calculations, but we want to make the observation here when these powers are even, both at the 4 and the 2, we're essentially going to get the exact same expression as we have here. So these will completely cancel off. And then you'll notice here with the odd exponent, we're going to get a negative 1/3 root of 3. And then we have, with that minus sign, that'll make it positive. So when we expand this out, let's make the following observation. And when you distribute that minus sign and evaluate with your exponents here, you'll notice here that what I have highlighted in red here, these will cancel, much like what I have highlighted in green. They also have cancellation. However, the two blue ones here, these are going to come together. Same with these ones here, these will come together. So we get the following. And you can see here 2/3 to the square root of 3 cubed. This will get some cancellation here, just simplifies to become 2 root 3 plus the 8 root 3. And our final answer here is 10 root 3. All right, let's take a look at another example. All right, for the following example here, we're taking the integral from negative pi over 3 to negative pi over 4 of the following function here. Again, we can tackle the antiderivative of each of these separately. So I'm going to go ahead and integrate 4 secant squared t first. Again, this is with respect to t. Recall the following. For f at t equal to tan of t, the derivative is secant squared of t. Therefore, we have the following. And you'll see here the antiderivative of secant squared is your tan of t, and then I have to put that 4 in front because we do need that 4 from before. Right here I went ahead, and if you write this in exponential form, you'll notice that this is actually pi times t to the negative 2. This is what I need to get here. So if I take the derivative of t to the negative 1, you're going to end up dropping down that minus 1, making it positive, which we needed, and then subtracting 1, you'll get your t to the negative 2. So we're going to go ahead and evaluate this from negative pi over 3 to negative pi over 4. And this gives us the following. So I went ahead and evaluated this at negative pi over 4, the function, and then at negative pi over 3. Let's take a look at our unit circle to find the tan of negative pi over 4 and the tan of negative pi over 3. And you can see here, take a look at our unit circle here. At negative pi over 4, we have the following point. So we're going to get the tan of negative pi over 4 is negative 1 here. And then at negative pi over 3, we're all the way over here, and it corresponds to the following point on a unit circle, and the tan of negative pi over 3 is negative root 3. Let's go ahead and sub that into the following equation and simplify. And substituting this in here, you can see I went ahead and subbed in the -1 for tan of negative pi over 4 and the negative root 3 for the tan of negative pi over 3. I also took our negative reciprocal here and flipped this and put the two minus signs together, making them positive. Did the exact same thing here, and then we get cancellation in the pi's, both here and here. Simplifying, we get the following. And you can see here we get -4 plus 4. Those will cancel off, and I'm just left with 4 root 3 minus 3 as our final answer. All right, that concludes today's lesson on solving some basic integration questions. Thank you.